Hello, everyone. Welcome to this video on learning mathematics through concepts and examples. In this video, we are going to solve Mastery Exercise 2 from your Intro to Statistics class. So let's begin with the example. Here is the first example. Based on the frequency distribution below, this would be below, find the relative frequency for the class with lower limit 15. So we have to find the relative frequency. As you can see here, we are looking for the relative frequency for the class with lower limit 15. Lower class limit 15. So if we look at this table given here, the class with lower limit 15 is this one because it is from 15 through 18. So that is the class, and we need to find the relative frequency for that. So if you remember, relative frequency is denoted like this, RF, okay? And the formula to find relative frequency is equal to frequency of that class divided by n is the total number of observation. And here we are asked to give the answer as percent. So we multiply by 100 so that we get the answer in percentage. Now here, the frequency of that class is 10 divided by n. N is the total, so we need to add all these. 10 plus 8 plus 3 plus 5 plus 4 is a 40 times 100%. And if we simplify, 10 over 40 multiplied to 100, that is 25. So it is 25%. It is the exact number, so we don't even need decimal. But if you want to write using one decimal, then you can write 25.0%. Okay, that is first example. Let's move on to second example now. Here is the second example. Again, based on the frequency distribution, this would be below. Find the cumulative frequency for the class with lower class limit 27. And we are asked to give the answer rounded to one decimal place. So here we are looking for the cumulative frequency. Cumulative frequency for the class with lower class limit 27. Lower class limit 27. So if you look at the table, the class with lower limit of the class 27 is this one here. That is the one. And we are looking for cumulative frequency. So cumulative frequency is the sum of the frequency of that particular class and all the classes before that. So in this case, it's going to be this one here, 5, then plus everything before that. So 5 plus 6 plus 8 plus 10. So 5 plus 6 plus 8 plus 10 is 29. So the cumulative frequency for this class is 29. So always remember, cumulative frequency is the sum of the frequency of that particular class plus all the classes before that. Okay, next example. So here, based on the frequency distribution below again, create a histogram for the data. So we are asked to create the histogram. And one thing to note here, in histogram, the bars are connected, okay? The bars are connected and the class must be continuous. But if you look at this class here, the class given here, 15 through 18, then from 18 we are jumping to 19, 19 through 22. So the class are not continuous. So what we do is, first we need to modify the class and make them continuous. So if I want to make this continuous, because there is a difference of 1 between the upper limit of the first class and the lower limit of the second class, and if you divide that 1 by 2, it'll be 0.5. So meaning of that is we subtract 0.5 for all lower limits, and we add 0.5 for all upper limits. So if we modify this one, it will be 15.5. I mean, for the lower limit, okay, for the lower limit, we subtract, so 14.5 up to, for the upper limit we add, so 18.5. Similarly, the second one will be 18.5 up to 22.5. And this one will be 22.5 up to 26.5. And then 26.5 up to 30.5. And then this one will be 30.5 up to 34.5. And the last class will be 34.5 up to 38.5. So first, we modify the class. So whatever we have here just now, okay, these are the modified class. Modified continuous classes. Because while making the histogram, we need the continuous data. So we make this data continuous. Here we have the frequency. Number of students is the frequency. It is here. So what we do is, along the x-axis, in order to create the histogram, along the x-axis, we'll include these classes, and along the y-axis, we'll have the frequency. So let's try to draw the horizontal line first. Okay, horizontal line, and this side, the vertical line or the vertical axis. Now we need to label this. We don't have to start from 0, so that's why you can put a clink on the x-axis so that you have shrinked it a little bit, and you can start from 14.5. So 14.5 to 18.5, 18.5 to 22.5, 22.5 to 26.5, 26.5 to 30.5, 30.5 to 34.5, and then 34.5 to 38.5. So these are the classes. But in this case, these are the ages of the students, right? Because if you look here, these classes represents the age. So age of a student will be here on this side along the x-axis. Okay, that is along the x-axis. Now along the y-axis, we need the frequency or the number of students. You can see the maximum number that we are going here is 9. So we can count by 2, 2, 4, 6, 8, and then 10. That means in the middle of each, you have the other numbers 1, 3, 5, 7, and then 9. So once we have this information, we can easily draw the histogram. So the first class has a frequency of 5. So for the first class, you can draw a bar with the height 5, like that. Second one has a height of 9. Okay, second one has a height of 9. And you can see, in fact, 3 of them has height 9. So I can draw all of them at once. 3 of them, they have the height 9. But let me show you that they are actually 3. I can draw a vertical line there. And the vertical line somewhere here. So you can see you have 3 of them. And finally, we have these 2 remaining. The next one has a height of 8. So let's draw the vertical bar with height 8 now. Over here, height should be 8, which is be a little less than 9, just like that. And then finally, the last one has a height of 5. So we can draw the one with height 5, which is the same height as the first one. Okay. You can also label them with the frequency. So 5, 9, 9, 9. This is 8. And this is 5. Okay, so all these frequencies are written here on the top. And if we add all these numbers, it will be equal to the total number of observations. This is how we can construct histogram. So key here is, while constructing the histogram, what we need to do is we need to make the connected bars. That is one thing. And in order to make the connected bars, these classes must be continuous because we create histogram for continuous data. Age is a continuous data. So that's why we need to modify this class to form the continuous classes. So that is the important thing that you need to note while creating histogram. Okay, let's move on to next example. This one here. So here in this example, let's see what we're asked to do. Data was collected for a sample of organic snacks. The amount of sugar in milligram in each snack is summarized here. Okay, summarized in the histogram below. What is the sample size? So from the previous example, what we know is if we want to know the sample size, we need to add all these numbers on the top of the bars. Okay, that is the sum of the frequency. So here, if we look at all these, for example, the height of this one is between 2 and 4, that is a 3. We can write it there. And for the next one, as you can see, it is exactly 2. For the third one, you can see it is 8. For the fourth one, it is a 14. Next one is a 10. The other one here is between these two values, right? Between 4 and 6. So that must be 5. And then this one has a height of 2 again. So the sample size will be n equal to, we add all those numbers, 3 plus 2 plus 8 plus 14 plus 10 plus 5 plus 2. So if we add all these, then n is equal to 44, or that is the sample size. So that's how we can use histogram to find the size of the observation. Great. Now let's move on to next one. This one here. Let's see what is given and what we are asked to do. The data in the figure below represents number of stars earned by 140 performers in a talent competition. So here you can see number of stars, no stars, 1 star, 2 stars, 3 stars, 4 stars, 5 stars. Okay. And you can see these stars are given to 140 performers. So the total number is 140. Okay, 140 performers. Now what we are asked to do is how many performers earn exactly 0 stars. So you have to look at the diagram here very carefully, because here you can see along the x-axis you have the number of stars. Along the y-axis, you have the percentage of performers, not the numbers. So if you look here for 0 stars, because we are interested in the number of performers who earned exactly 0 stars. So if you look at the graph, and if we look at 0 stars, you can see 20, right? 20. This is 20. But remember, this is not 20 performers. It is 20%. Because we have the percentage of performers along the x-axis. So this is 20%. But the question is how many performers? So that is 20% of 140. So we can write like this. 20% of performers got 0 stars. That's what we know, which is equal to 20% of 140. Total is 140. So we can write that as 0.2, 20% of 140 times 140. So 0.2 times 140, that is 28. So meaning of that is 28 performers got 0 stars in that talent competition. So you have to be very careful with what is given along the x-axis or y-axis. Along the x-axis, you have the stars. Along the y-axis, you have the performers percentage, not the number. But the question is asking for how many. That is, we are looking for number there, right? How many? So in order to find the number, it is the 20% of 140, which will be 28. Okay. Okay, here we have the other problem. Look like that's a long problem, so much information given, but let's find out what is there. Is there a relationship between autism and what an infant is fed? So they are looking for the relationship between autism and what is fed, right? What an infant is fed. To determine this, okay, to determine if there is a relationship, a researcher asks mother of autistic and non-autistic children. Okay, so what they are doing is they are asking the mothers of autistic and non-autistic children to say what they fed, right? What they fed. So here we're looking at two things. One is whether the child is autistic or not. And the second thing is what is fed. And they have created a table here. You can see the first variable that they are observing is autism. Okay, whether the kids have autism or not, yes or no. So one variable that is being observed here is the autism. Okay, this is one variable, autism. And the second variable that is being observed here is what they are feeding. Okay, what they are feeding. Here is that, what they are feeding. So you can see here, the first thing under feeding is breastfeeding, denoted by B, formula with DHA or ARA, that is formula with the DHA or ARA, so FW, and then formula without DHA or ARA, that is formula without FWO, and they are given the total. So you can see the total is along the last column, or over here, I mean, in the last row, and also in the last column, we have the total. Okay, now let's see what is asked. Using the following data, create a graph to represent the data. So you can see that in this example, data involve, let me write, data involve two qualitative, right? Two qualitative variables. Two qualitative variables. One is autism, yes or no, and the other one is feeding, what they are feeding, breastfeeding formula with DHA or formula without DHA. Okay, so two qualitative variables. So because the data involve two qualitative variables, the best way to represent with the graph is, the best graph will be, best graph will be side by side bar graph. It will be side by side bar graph. If you have only one variable, then it can be one bar graph, but there are two variables. So that's why we can make side by side bar graph. We cannot make histogram because this is the qualitative data. If it is quantitative data, we can make the histogram. So two qualitative variables are involved. Because of that, we can make side by side bar graph to represent that. And now we are going to create that side by side bar graph. So what we do is, in order to create this type of graph, it is not very difficult. All you have to do is along the x-axis, okay, along the x-axis, we can have what is the feeding. So along the x-axis, we'll write feeding. Let me write that. And along the y-axis, we'll have the numbers. Okay, along the y-axis, we'll have the numbers. because you can see the numbers here are 10. 10 babies are on breastfeeding. They have the autism. That is the meaning. For example, if you want to understand this 64, let's say 64 for the babies are on formula without DHA, but they have autism, just like that. Okay. So here along the y-axis, we'll have the frequency, and you can see the maximum number that we go up to is 64, right? Because the core data is here. This is the core data. Here is the information. We need to adjust those numbers along the y-axis. So we go up to 64. So let's try to count by 10 if possible. 10, 20, 30, 40, 50, and then 60. And we are drawing the side by side. So what you do is we'll put the breastfeeding habit over here with yes first and then with no second. So what I mean by that, let's first make it. So breastfeeding B, here also let me do breastfeeding B. Then formula with DHA, formula with DHA, then formula without DHA, formula without DHA. So along the x-axis, we have the feeding. You already know that. Now, the first one is for the babies with autism. Yes, let me write yes. And this side, babies without autism or no. Now we can draw the vertical graph, okay? So, for example, breastfeeding and autism is there. Breastfeeding, autism is yes. So that is a 10. So when you draw a bar, you draw it like that. If you connect them, it really doesn't matter whether you connect or not. So if you want to draw the second bar connected there, that's totally fine. Next one, you can see formula with DHA, 38, and that is a yes. So 38, pretty close to 40, just like that. And then the next one is 64. So this is going to be the tall one, a little bit above 60. Just like that. Okay, and same thing over here. Breastfeeding, no autism. 10 of them again. Breastfeeding, no autism. 10 of them, just the equal height. Next one, formula without DHA, 22, no autism. So the height will be 22 here. And then the next one, we have 10 again. Just like that. So that's how we can create the side-by-side bar diagram to represent the data involving two qualitative variables. Here, as I told you, two variables were the feeding, what is fed, and then autism, whether they have autism or not. Okay, let's continue. We have a few more remaining. Next example here. This is based on the pie diagram, as you can see. So let's read through the problem and try to answer it. Courtney categorized her spending for this month into 4 categories, as you can see here. And those 4 categories are rent, food, fun, and other. The percentage she spent in each category are pictured here. So rent, as you can see, 27%, right? Rent, 27%, food, 23%, fun, 15%, and others, 35%. Now, what we are asked to do is, if Courtney spent a total of 2,200 this month, that is the total spending. If Courtney spent a total of $2,200 this month. How much did she spend on food? You can see here she spent 23% on food. So that's where we start. So amount spent on food is 23% of the total amount is spent, 2,200. 2,200. So which is equal to 23% means 0.23 times 2,200. So 0.23 multiplied to 2,200 is 506. So she spent $506 on food this month. Okay, so it's quite easy because they have given the percentage and the total is spending. So the amount spent on food will be 23% of 2,200, which will be $506. So that is the quick application of the pie diagram. Here's the other one. Let's see what is given here. Okay, here, given the data set, summarize as a stem and leaf plot. So they have given the data in the form of stem and leaf plot here. Okay, so these are the numbers on 20. So meaning of that is this is 20, 20, 20, 21, just like that. Okay, now the question is how many data values are in the set? So if you want to know how many data values are here, for example, for part A, let me write here. Okay, for part A, the total number of observation will be equal to how many data sets? So here you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So over here in 20s, we have 10. Plus, similarly, you count here how many are there. So that should be 10, 11, 12, 13, 14. Plus 14. Similarly, here we have 1, 2, 3, 4, 5. 5. And in the last one, we have 3 of them, which implies n is equal to, if you add, it is 32. So the total number of observation or how many data values are there in this data set, that is 32. What is the minimum value? You can see the minimum is this one, 2020. So minimum is 20, right? But the question is, what is the minimum value in the last class? 20 is the minimum of everything, but this is the last class. In the last class, we have 50, 50, 56. So the minimum value in the last class is 50. Minimum value in the last class is 50. Okay, so let me write the next line there so that you don't get confused right here, 50. The next one is, what is the minimum value in the entire sample? For the whole sample, the minimum value is 2020 because that is all the way on the top, 20. We don't have anything smaller than that. How many of the original values are greater than 40? Now you need to look at where is 40. 40 is here. This is 4040. Here we have 1, 2, 3, 4 of them more than 40. And here we have 3 of them. So that is 4 plus 3 equal to 7. So 7 data values are greater than 40. So this is the quick analysis of the stem and leaf plot. So sometimes the information will be given and you'll be just asked to analyze the stem and leaf plot like this. So we are just understanding the stem and leaf plot here. Here we are not asked to create the stem and leaf plot, but in the other example, the next one, you'll be asked to create the stem and leaf plot. And here is that example. You can see there are a lot of problems here, but it's not very difficult. So let's try to solve it. Student in the statistics class took their first test. The following are the scored they earned. Here's their data. Fill in the stem and leaf plot below. Use the tens place as the stem and ones place as the leaf. We know that. Describe the shape of the distribution. So first question here is, how many variables are involved with the given data? So you can see over here, we just have only one variable, right? It's only the test score, scored they earned. Okay, so how many variables are involved? That's one variable, one. And also you can see that this involves pure numbers. So I can say one, and that is quantitative variable, right? One quantitative variable. One quantitative variable. And also, so that is the answer for how many. Also here, what they ask is or are the variables qualitative or quantitative? We already did that. Is it possible to create a stem and leaf plot? Yes, because the data involve one qualitative variable. So answer for this one is yes. Yes, we can create stem and leaf plot. If we can create, we have to create it, right? That is what is the second one. If possible, create the stem and leaf plot. So in order to create the stem and leaf plot, what we do is we draw a vertical line to separate the stem and leaf like this. And then you can see that we have the data values in 50s, we have the data values in 60s here, we have the data values in 70s, 80s, and 90s. So we'll write like this. For 50s 5, 60s 6, 77, 80s 8, and the data values in 90s 9. So these are the stem. Okay, this side we have leaves. For example, let's look at the data values in 50s. Okay, let's find the data values in 50s. So if you look carefully, we have everything in 90 here. Here is 53, as you can see, right? There is a 53. I hope you can see it. Let me show you like this. There is a 53. So you have to look at it very carefully. Okay, you have to look at it very carefully to see whether there are numbers in 50 or not. Here is the other one. Let me show you one in detail. Nothing there, nothing there, nothing there. So for these two numbers, when you write the leaves, it will be 53, it's 5, 3. Okay. And then 59, 5, 9, like that. Similarly, in 60s, if you look for 60s, here is a 6060. And then look very carefully, there is 6262. 60, 62. So that's how you can fill it. You have 71, 271, and then you have a 72 and 74. Similarly, you have 81, and then you have 282, 82, 82. Then you have 285, 85, 85. Okay, and then 86, 89. Similarly, let's do the last one. There are 292, 92, 92. Then 393, 93, 93, 93. Okay, there are 395, 95, 95, 95. I don't have room. I'll write down here. 97 is there, 98. We have two of them. So that's how we can create this stem and leaf plot. Okay, so we have to write all stem here and then leaves on the other side. Because this data is quantitative data, you can definitely create the stem and leaf plot. Okay, let's see the last problem for this exercise now. Here is the last one. So in this one, the point is scored by winning team of the Super Bowl champion between 2005 and 2019. 15 games are listed here. And here we have the data, as you can see. We are asked to complete the stem and leaf plot for this one. So if we want to create the stem and leaf plot here, so what we do is, just like in the previous example, we are going to draw the vertical line. to represent the numbers. You can see we have 13 number in 10. So there's also 40, 30, 20. Okay. So we have numbers in tens. That's from 10 up to 19. We have numbers in 20s. We have numbers in 30s. We also have numbers in 40s. So if you want to see in 1, we have 1, 3, 13. Okay. And then 1, 7, 17. 13 and 17. Similarly, in 20s, you can see 24, 28, 21, 27, 29, 21. So we have 221, 221, 224, okay, 127, 128, and 129. Similarly, there is 131, so 31, 231, so 31, 31, and 234, 34, 34. And we have 41 and 43. So this is how we can create the stem and leaf. So this side it is stem and this side leaves. So that's how we create a stem and leaf plot. That is the first thing. Now you must put comma. I did that for the leaves. We did that. Now what is the SOCS of the distribution? Okay, let's see. SOCS. Let's talk about this briefly here. When we say S means the shape. Okay, S is the shape. Let me write like this. Shape is S. So if we quickly look at this one, okay, here the lower numbers are on the left side. If we rotate this, so this will be towards the left, this will be towards the left, right. This side is right, that side is left if we rotate it. So here is the tallest bar. This side we have the shorter length of the distribution. This side we have the longer length of the distribution. So meaning of that is the data is skewed to the right. So the shape will be right skewed. Okay, for the shape, we can say it is right skewed. Right skewed. That is S. O is there. Meaning of O is, are there any outliers? Outliers is O. That is, compared to the other values, are there any numbers which are significantly small or significantly large? We don't see that. There are two numbers in this one, couple of numbers here. If there was one number like 90, that will be a very big number compared to other set, that will be outlier. So here we can say there are no outliers. No outliers. That's for O. Okay. Now C is the center. C is the center. Center is C, sometimes referred to as median. This is also the median. Median is the value in the middle. What value is in the middle? Now, if you count how many values are here, you can count here or you can count here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So if there are 15 numbers in a row, the seventh number will be in the middle. So that 7 will be below and 7 will be above. So if you count 7, eighth will be the middle. 1, 2, 3, 4, 5, 6, 7, 8. This is in the middle because there are 7 numbers smaller than that and there are 7 numbers more than that. So this is in the middle. That is the median, which is 28. So the median is 28, or the center is 28. Okay, that is C. Now the last one is S. S is the spread, or it is also called the range. Range is the value from the smallest number through the largest number. Smallest is 13, largest is 43. That means the range is from 13 through 43. So we say 13 through 43. Meaning of that is we have a range of 30. Okay, 13 through 43. If we subtract, that will be 30. So this is how you can solve your second mastery exercise. Okay, this is how you can solve your second mastery exercise. Thank you so much for watching. I hope this video is helpful for you.